Hello everybody, this is Dro. Welcome back to the 5th episode of the Redstone tutorial series. And today we're going to talk about monostable circuits, also known as edge detectors. But before we detect any edges, we need to know what they are in the first place. So we know that redstone dust can have two states, which is off and on, and an edge is the transition between those. So we have an edge right now and right now. And those two edges have two names. We have a rising edge from off to on and a falling edge in the other direction. And what an edge detector does now is it gives an output when the edge it's made for, so either the falling edge or the rising edge, is triggered. So it looks like this. We have an output that's always off, except for a brief moment when we power the input. And when we turn it off, nothing happens. So that is an edge detector, a rising edge detector to be more precise. And they are also called monostable circuits because they have two states, which is on and off, obviously, and only one of them is stable. So in this case, the off state is stable. And when we turn it to the on state, it's unstable and will go back to the off state after a while. So that's why it's called monostable or edge detector. But how can we build something like this? Well, first of all, we need an input and an output. That's very obvious. And if you think about it, if we only have one signal line, what I mean by that, I tell you in a moment. We can only delay or invert a signal. Now, let's see, if we have two signal lines, it would look like this. We have a line up here and a line up here, or down here, for example, and that would be two lines already. So that might work out. So what we try to do is we split the signal into two lines and connect it with a logic gate in the end. And here's another small hint. We need some sort of timing component to determine for how long the output will be on. So that's a hint to using a repeater or two or several. If you use a repeater, then make sure you use like 2 or 3 and have a high delay, because that will make it clearer what logic gate you need in the end. So if you feel like you can build it by now, then go ahead, try it in a test world. And if not, I'll see you back for another tip. So the final hint, we just put some repeaters on one side, and I take quite a few here with a bit of delay to make it more visible what should happen. So now we take a close look at those. When we flick this on, the output should be on, so take a look at those, what they do. So this one turns on instantly, and this one turns on after a brief while. So that means when this one is on and this one is off, still off, when this is still off, then we want the output to be on. But when it's on and when it's off, that is that stinking implies gate over there. So we don't really like that. So let's just invert one input and see what happens, because as I said last time, an implies gate is just another version of another gate where just one input is inverted. So let's try inverting this input and see what happens then. So nothing should really happen when we flick it off. So when we flick it on, we see that both need to be off for the output to be on. Or in other words, if neither this nor this line is on. Let me try that again. When neither this line nor this line is on, the output should be on. So that means we need a NOR gate. Yay! So I want you to build it, and I'll see you right back. So the solution should be quite obvious. There are two ways of thinking about that, and I'll show both. So the first one is what I just said. We just put a NOR gate there. That works just fine when we flick it on, when we give it a rising edge. It turns on, and else it doesn't. And the other way would be we think about it as this input is inverted and not this one. So I'll just change that real quick. And then it does some funky things here. And if we do that, we would need an AND gate here. And now this works quite as well. But you see we have an inversion here, an inversion there, so we can take it out because it's a double inversion. And then it's the same deal as before. We have an inversion on the side where the repeaters are not, and then a torch at the end. So that is how you can build a monostable. Now, uses for that, we can limit the pulse that buttons give. This is called a pulse limiter in that case. We're going to talk about those a bit more in the next episode. Not really much. And this one is one that allows for very, very short pulses, which makes very weird things with a sticky piston. Why that works, we're going to talk about in the next episode, because we're going to talk about pistons in the next episode. And monostable circuits are also used in things like piston doors, which we're also going to take a look at quite soon. But let's get on. We have also the same thing on the falling edge. I think you should be able to do that quite easily. So I want you to build that one. That is very similar to this one, so it should be very easy for you to do that. So see you guys in a bit. So there are two possibilities to do that, and I'll show you both. So the first one is just invert the input and do the same thing as over there, which sounds a bit cheaty, but it works. Then we build our sort of implies gate there, connect a bit of redstone to that, and redstone lamp in the back, or another output block, and that triggers on the falling edge. And the other method would be we just invert the other side of the logic gate. So let's see. Yeah, we do it like this. Place a torch there and a lamp here, and that works just as fine. Now, what you should need to know is that there are also things called dual edge detectors. This one is probably the most common design. And yeah, as the name says, they detect both edges. Why that works also in the next episode. And what I want to do, or what I want you to do as a home assignment, is build a falling edge detector and a rising edge detector in as small space as possible. So, thank you very much for watching. This has been Dro. Give a like if you enjoyed it, if you learned something, and I'll see you next time.